Hello friends, welcome to the very first episode of our brand new series called The 100 Challenges of Python for Better Understanding. In this episode we work together to implement 7 different basic mathematical equations with Python programming language. Let's fine-tune your Python skills with engaging way by solving problems to understand the concepts. I am Dilan Chandrajit here from zeklabs.com to help you to improve yourself as a techie person. If this is the first time you hear about us, we are Zek Labs. We publish tutorials, courses and explainer kinds of videos on software engineering, cybersecurity, Linux and etc. In this episode, we practice 7 Python challenges to understand the basic arithmetic operations in Python. We cover all the basic arithmetic operations such as addition, subtraction, multiplication, division and modular operation as well. In each challenge, we solve them with proper explanations. In this video, our focus is to solve challenges. So I don't explain about those arithmetic operators much. For now, just take a look at them. The first arithmetic operator we have is addition. With this operator, we can add two numbers each other. In Python, we use plus sign to denote the addition arithmetic operator. As the example I provided, we just can add two variables or values each other with that basic syntax. The other arithmetic operator we have is subtraction. We can use this arithmetic operator to subtract one value from another. Almost all the programming languages are using minus sign to denote this operator. The third one of them is the multiplication. With this arithmetic operator, we can multiply two numbers. In real world, we use cross sign to denote multiplication. But in programming, it's little bit different. We use asterisk sign instead. The last of the very basics arithmetic operators in Python is the division. We can divide two numbers using this operator. Python uses slash sign to denote it. So, here we covered all the basic arithmetic operators of Python. So let's take a look at some advanced arithmetic operators out there. When we talk about complex arithmetic operators, there are 3 of them. These operators can be used for doing complex mathematical operations such as modulus and exponentiation. So, let me explain them. The first one of them is the floor division. In most cases, we call it as integer division also. It can be used to find the floor or the integer part of the quotient when we divide one number by the other. In Python, double slash signs are used to conduct this operator together. The next one is the modulus. We use this operator to find the remainder when the first number is divided by the second one. You can use percentage symbol to initiate this operator in Python. Before we move to the next operator, let me clarify these two operators. As an example, let's say 7 divided by 2. We all know that the answer is 3.5. And the same time, we can say that 7 is equal to 3 times 2 plus 1. In that case, 3 is quotient and the 1 is the remainder. Let me simplify it. It means that if you divide 7 by 2, we have 3 of 2's and 1. If you look those two examples carefully, here we can see that 3 is the output of floor division and 1 is the output of modulus. Then we can simplify the idea. Floor division returns the quotient and modulus operator returns the remainder. I hope you understand the operations clearly. So, let's move into the last operator. It is the exponentiation operator. We use double star symbols to conduct this operator in Python. This operator can be used to raise the one number to the power of the other. So, here we quickly recap the theories about arithmetic operators. Now it's time to move into the best part of this episode. Let's start with a simple mathematical equation. The first challenge is to create a Python script to calculate the circumference of a circle. If we know the radius of the circle, we can calculate the circumference of it using the equation 2 pi r. Before the first line of code, let me explain of the setup in my machine. I am using Ubuntu 20.04 with Python 3.8.10. Since Python 2 is deprecated as today, I recommend all to use Python 3 for development. And the same time, it's better if you are using 3.8 or higher version. I use VS Code editor for these series. It has all the features we required for these kind of development. But if you are familiar with something else, please feel free to use that editor. Here I structured the code episode-wise. So I have a directory called episode1, and I created a Python file called 1circumference.py inside it. If you are very beginner, we have to save Python scripts with the extension py. It says the operating system that this is a Python file. Inside the file, let's code the very first line of the script. We know that we gonna need a constant called py. So first, let's define that constant. So I gonna type py equals 22/7. If you noticed it, I write py in all block letters. The reason is, it's a constant. We don't have keyword like const in Python as some other programming languages. So, we write constant in all capital letter as a standard. Then other developers who contribute to your code might know that this is in constant and I should not override it. In the best coding practices, we define constants in a separate module as well. But for now, let's keep it simple. So I define the constant inside the same file. Next, I write a function to calculate the circumference of a circle, where we provide the radius. In Python, we use def keyword for defining both functions and methods. So, let's define the method by coding def_getCircumference. Then inside the brackets, we pass the variable called radius. That means, when we call this function, we have to provide a 1 value. It's mandatory. Then Python interpreter will assign that value to the variable called radius. That variable is only applicable inside this function. At the end of the line, we put colon. It's the end of the definition of the function. In most cases, people are confused with methods and functions. Methods are associated with classes. But functions are not. So, what we defined here is a function. Now, we are done with this line. So I press enter. But, when you get into the next line, if you noticed it, the cursor is not in the very beginning of the line. It's in the middle somewhere instead. In Python, we don't use brackets to define the code block of the function. It's same for the code block of class, method, if statement or loop as well. So, there should be a way to interpreter to understand which codes are located under the code block of this function. So, we say the interpreter that these are the code block under this definition by indenting that piece of code. If you see indented code block somewhere in a Python script, it means that code block belongs to the very first definition you see above it. It may be a class, function, or even a loop. If you are using a regular text editor like Notepad, we have to do indentations manually. But this smart piece of software called VS Code do it for us. That's why developers tend to use IDEs when they do development. They are shipped with a lot of functionalities that make developers' life easy. Inside the function, we have a very simple implementation. We calculate the circumference of given radius and return it. So, I type return to pi and radius. As we discussed early, we use asterisk instead of cross sign as you see to conduct the multiplication. So, there we have something to clarify. Return keyword is used for returning a value from inside the function to the outside. At the same time, remember that if you have a return keyword inside a function, when it gets executed, Python exists from that function. So, all the code inside the function, after the return keyword, will not be executed. Now we have implemented a function to calculate the circumference of the circle when we provide it with the radius. But we have to execute that function to calculate the circumference. So, let's execute it. I code if Dunder name equals Dunder main. And again at the end of the line, we put colon. Here we have bunch of new stuffs to talk about. First, if you hear an odd word like Dunder, it is a commonly used short term for double underscore signs. Most Python developers tend to use this word. As you see, the line starts with keyword if. This is our example of basic if statement. Dunder name is built-in variable in Python. It evaluates the name of the current module. Even if I called it Dunder name, actually it has double underscores before and the after the name. But we say Dunder name because it is easy to pronounce without following Dunder. Then we have double equal signs. In programming, we have another type of operator called relational operators. But for now, keep that topic for another day. In summary, if you see double equal signs, it means that the operator checks whether the value on the right side of it equals to the value on the left side of it. If they are equal, that operator returns true value. It returns false otherwise. But not like that operator, single equal sign has different meaning. What the equal operator does in Python is assign the value on the right side of it to the variable on the left side of it. If you noticed it, we already used it for once. We assigned the value 22/7 to the constant variable called pi in the very first line of this code. Moving into this if statement again, this piece of code asks interpreter to execute the indented code block only if we directly execute the script itself. I'll explain the concept when we solving a challenge with more than one modules. For now, keep this challenge simple. Then I use indented block again to specify the code block of the if statement. As you see, I already entered to the next line with indentation. So, I code circumference equals underscore get circumference. Inside brackets, I put the value 7 between the brackets at the end. As I already mentioned when defining the function that it required a mandatory variable called radius. So, the value 7 we put here is going to be assigned as the variable radius. As a quick recap, with this line, we ask interpreter to call the get circumference function with provided parameters. And then assign the return value from the function as to the variable called circumferences. In the next line, we use print statement to print the value we calculated. So, we type print and inside brackets, we again put quotes. Inside quotes, I type what I should print. Here we put something like, circumference is. So if you note it, it's not like with some other programming languages. In Python we can use both single and double quotes to specify the strings. After the string part, I put a comma and the variable name I defined in the above line. So, this line prints circumference is 44 for the given radius value 7. So, the coding part is completed. Now it's time to execute the script. You can see, we have the terminal in the down there. It's called the integrated terminal. In the terminal, we type the Python 3 command following the name of the Python file. And hit the enter. So we can see that, we have the same output as we expected. As we know, for a given circle with the radius of 7, circumference is 44. I am using Python 3 command here because I use Python 3. In Ubuntu, Python 3 refers to the Python 3.x versions and Python command is for Python 2.x versions. Even for Mac OS, it's same. But if you are using Windows, you might have to use Python command, even you used Python 3 on it. Let's pass the value 3.8 to the function instead of 7. And then we can run the script again. Now we can see that, we got something different than 44. So, our script successfully calculated the circumference of a circle with radius 3.8. Now it's time for the next challenge. In this challenge, we write a script to calculate the area of a circle when the radius is provided. The equation for calculating area is pi r squared. Same as the last time, I created a new file called 2-area.py under the episode 1 directory. And, if you notice, I create another file called 0-template.py. So, here is the simple template we use for whole episode now on. The file I already opened is also a copy of the template file. At the very beginning of the file, I put a comment. That area is intended for the constants we define. As a quick recap, we can use hash symbol to initiate a comment in a Python script. It will comment the line beginning from the symbol, all the way to the end. We use this feature in programming languages to put some comments about the code. When Python interpreter interpret the code, it simply ignore all the thing following the hash symbol. In the same way, we reserve the next space for methods. But in this case, we don't use classes. So that area is for functions instead. At the end of the file, we have a code block to identify whether we run this file as a script or module. We already talk about it. We can go deep about this concept in the future. But if you notice it, we have another keyword called pass under the if statement. So let's clarify it. It may be very helpful. We already know that we have to use indentations as Python to define a code block. So, it's same for the if statement we have at line 6 also. Under that statement, we have to have an indented block. But still, we have nothing to implement under this if statement. So, we simply put pass keyword there with proper indentation. Then Python interpreter knows that the if statement we mentioned has no implementation yet. So it doesn't throw an exception. But we still have another line other than pass keyword with proper indentation. Since it starts with hash sign, interpreter knows that it is a commented line. So it doesn't count that line. And I missed one important thing. Here in all the comments, I use 3 hash symbols with 1 dash sign. But it's not necessary. The first hash sign is enough to make the whole line as a comment. I just personally use this 4 symbols when I commenting. It's just my preference. So let's start coding. As the first step, I remove the pass keyword and the commented line under if condition. We know that we are going to calculate the area of the circle. So I type area equals underscore get area. Within the brackets, I put the value 7 again. But we can see that VS Code underlines the function call with red color. The reason is VS Code is trying to warn us that there is no such a function. So let's define the function. I move my cursor to the line 4 and hit enter. So I have space to add the new function. Then I type def underscore get area. Within the brackets, I put radius. The reason is, in order to calculate the area, we should tell that function what is the radius is. So in that way, I pass the value of radius into the function. In this case, we put 7 already in the line 8. But here we have another important thing. If you see it carefully, I put underscore sign before the name of the function. I am pretty sure that most of you didn't see something like this before until our last challenge. But there is a reason to do so. If you are familiar with Java, you already know that in those languages we have access modifiers. So, when we define a method or variable in Java, if we put private keyword before the name, it means that this method or variable is only for internal use. We can't access it from the outside. But in Python, we can't restrict the access like that. So, again we come up with a standard. We starts functions and variable names with underscore to convince that this is a private stuff. So others can avoid accessing it from the outside of the module. So, let's implement the function. Here I type, return pi times radius to power 2. As we discussed early, we use one asterisk sign to denote the multiplication. In the same time, we use two asterisk sign together to conduct the exponentiation operator. So, this function calculate and returns the area when we provide it with a radius value. But, VS Code warn us again. It says something is wrong with the constant pi. The reason is, we still didn't define it. So let's move up and type pi equals 22 over 7. So, we use all capital letters for the variable pi, since it is a constant. All the work are done for calculating the area of a circle. We create a function that capable of calculating the area, and we made the function call at the very end of the file. So let's finish this thing up. In the end of the file, I am going to print the value we calculated. So, it's basically same as the last time we did. Since all are good, let's execute this script. In the terminal, we type Python 3 command with the file name. And, finally we see that, it prints the answer as 154. For the one last time, let's change the radius value and execute the script one more time. For the radius value 3.9, we got the answer as 47.80 and something. So, we solved this challenge also. In the third challenge, we calculate the area of a triangle. We can calculate the area of a triangle with the equation 1 over 2 times base times height. So, I code this challenge in the Python file called 3-area triangle. Like last time, let's start by deleting the pass keyword and the commented line. So, I assign the calculated area of the triangle to the variable called area. So I type area equals underscore get area. Inside the brackets, I put base comma height. So, we can see that this method we need to calculate the area should be provided with the base and height values. So, let's start with defining base and height variables. Before the function call, I declare base variable as 22 and the height variable as 13. Not like last time, in this time I didn't directly pass the variables to the function call. I did so because it's much readable. Now anyone can see that base is 22 and the height is 13. In up there, I define the function. So I type def underscore get area. We pass two parameters to the function as base and the height. Under the definition, I implement the function and return the value. So I type return 1 over 2 times base and height. But if you already noticed it, I surrounded 1 over 2 with the brackets. As a quick recap, we can use normal brackets to change the order of operations. I'll explain about this operator in the last challenge in this episode. But keep in mind that, in this case, brackets do nothing other than the visual effect. So, as the last piece of code, let's print the area. So, in the down there, I type the print statement. I execute the script by typing the Python 3 command with file name in the terminal. When I hit the enter button, here we have the answer. For the last time, let's change the base in the height as 10. And when we execute the script again, here we get 50 as the answer. This is the end of another challenge of the episode. In the next challenge, we have very simple task. We have to write a Python script to calculate the sum, difference and the product of given two numbers. But in this task, we don't hard-code the values like early challenges. We actually collect the numbers from the user instead. The other importance of this task is, here we using more than one functions within the same task. So, let's start coding. Here, I code inside the Python file called for-arithmeticOperators.py. In the first approach, let's hard-code the values. So later we can get those variables from the actual user. So, here I declare the val1 and val2 variables. Let's assign them 10 and 15. Again, here we have something to discuss. If you notice this, in all the challenges I used underscore sign a lot when naming functions. Here, I used that sign in the variable naming for the first time. But, did you identify that I used underscore to separate the words of a name also? Here, instead of typing val1 in a single go, I used underscore sign to separate the word val and the number 1. The reason is, then anyone can read its name clearly. We call this naming convention as the snake case. If you're familiar with Java, we use camel case naming convention there for doing the same. In camel case, we starts with simple letter and when we need to separate words, we start the second word with capital letter. But in most cases we use snake case in Python. We use snake case naming conversion for variables, methods and functions as a standard. I noticed that some developers using camel case everywhere in Python. But it's not the Pythonic way. In Python, we only use camel case for naming classes. But in that case, we start the class name with capital letter and then continue with camel case. I think that's enough for naming conventions. We can learn about it in a separate series in future. The first task of this challenge is to calculate the sum of given two numbers. So, let's make the function call. I assign the sum of two values into the variable called sum. So I type sum equals underscore get sum. If you noticed it, we again use snake case here for separate the word get and sum. So, let's define the function up there. I type def underscore get sum. Inside brackets I pass val1 and val2 to the function. The implementation of this function is to add two values and return it. So I return val1 plus val2. That's all for this function. So I write print statement to print the sum of two numbers under the function call. If you noticed that, I already made a comment before the getSum function call. The reason is, in that way I can tell others, here is the code block for summation. The next task of this challenge is to calculate the difference of val1 and val2. Let's put another comment for difference. I assign the difference of two values into the variable called diff. Here we are not talking about the just simple operation as val2 minus val1. What we calculate here is, what is the absolute value of the difference of two numbers. So, difference is always going to be a positive value or 0. I type diff equals underscore get difference. Inside brackets, I pass val1 and val2. So, after the getSum function, I define the underscore get difference function. Inside brackets I pass val1 and val2 to the function. The implementation of this function is tricky. First I type, return val1 minus val2. But what we need is the absolute value of it. So I surrounded the mathematical part with brackets and put ABS in front of it. Here is another quick recap. You can see that, what we ended up is something like return ABS and inside the bracket we put val1 minus val2. So, ABS is a built-in function of Python. If we pass any integer or float value to it, it returns the absolute value. Which means, even I pass minus 5 or the just 5, it returns with the 5. So, we pass val1 val2 to the ABS function. Both val1 and val2 are numbers itself. So subtraction of those two also a number. It will return the absolute difference of val1 and val2. So, that's it for the function. Let's print the difference. I put the print statement for difference at the end of the file. The last task of this challenge is to calculate the product of val1 and val2. So I put another comment for product. And then, I type product equals underscore get product. In up there, after the get difference function, I define the underscore get product function. I type def underscore get product. Inside brackets I pass val1 and val2 to the function. In the next line, I type return val1 times val2. So, that's it for the function. Let's print the product. I put the print statement for product at the end of the file. So, all the functionalities are completed. We have three functions to calculate sum, absolute difference and the product of val1 and val2. Before we make further any changes, let's check whether this code working fine. So, in the terminal I type Python 3 and the file name. It prints the answers. So we can see that answers are correct. So let's interchange the values of val1 and val2 and execute the code one more time. We can see that we got the same answers again. That means we calculate the absolute difference perfectly. So, now it's time to make some changes. Until now, we hard-coded values to the variables. But the name, variables, itself says us that it can be vary. Instead of hard-coding the values to the variables, we can ask user to insert some values and assign those values to variables. That's what exactly we are going to do. So let me delete the value 15 we have in front of the val1 and type the word, input. Inside the brackets, I put a string saying enter value 1. Again, we have something here to clarify. As a quick recap, I'll explain what the input function is doing. We all know that print function lets us to print something on the terminal. Input function is doing the exact opposite of it. It allows us to take an input from the user over the terminal. So what this line exactly do is, it print the string, enter value 1 inch in the terminal, and then a Python script waits until user enters something. Once user types something and put enter, input function took that phase and assigned it to the variable val1. But we have a problem here. Input function is taking all as a string, even we enter an integer or a decimal number in the terminal. Since val1 should be a number here, we have to convert the user input into a number. So I surround the input statement with brackets and put float in front of it. If you are familiar with languages like C and Java, in those languages we have variable types such as integers and floats. Integer is a full number which is not a fraction. It is a whole number itself. Float is a variable type that is not an integer because it has a fraction part on itself. In those languages, when we define a variable, we have to say what is the data type of it each time. Even though in Python, we don't care about it that much, it allows us to do conversions between number of data types. What we do here is an example of it. Float is a built-in Python function. If we pass something into the float function, it convert that thing into a decimal number if possible. I mentioned the word possible because you have to be careful when you're using those functions. If you pass a string like ABC to that function, it will crash the your script because ABC are 3 letters together. Python interpreter can't convert it to a decimal number. But if you pass a string contains a number like 23, float function converts it to the decimal number 23.0. In the same way, we can use int function for converting something to integers. By using int function we can convert anything into a string. And even we can convert decimal number to a whole number and remove the fraction part using int function. In most cases, we call this concept as typecasting. As we discussed, input function returns a string to the variable if we leave it alone. So, we have to convert the user input into a number. We can use both int and float function for the conversion. But since float function allows us to handle decimal numbers as well, I think it's the better choice for us. That's why I used float instead of int here. And I have to explain the one other thing. Float function will crash if we pass something which is not a number into it. But the user can type anything they want and hit enter. So our code will crash if user types something else. We can avoid these type of issues with exception handling. But it is another big topic. So let's keep it for another episode. For now, I don't use exception handling because I need to keep this thing simple. So I move forward. But be aware about these kind of issues when you write scripts. Then I do the same thing for val2. And that's it. Let's run the script and see how our baby is working. So when we execute the script, it asks us to enter the value 1. Let's type 10 and press enter. And then it asks for the second value. I type 10 again and enter. So you can see that our script calculate the values and print the answers in the terminal. That means it is working great. Let's run the script one more time. This time I insert 15 and 24. We can see it calculate the answers again for new values. So that's what I told about variables. They tend to be changed. In this case, our program picks the two values and assigns them to variables called val1 and val2. Then it does the calculations according to them. I think you got the idea. And that's it. We successfully completed another task on our list. But before we move into the next challenge, I have one quick recap and announcement. You can see that, after we get the input from the terminal, our answers has decimal points. I insert 15 and 24 in the last go. But float function converts them to 15.0 and 24.0. So, we add 15.0 and 24.0. That's why we get the answer as 39.0 with decimal places instead of the integer 39. We can dive more deep into those concepts in the future episodes and series. But for now, just remember it. The announcement is, I think that we already practiced simple functions and arithmetic operations in the previous challenges more than enough. So I didn't spend much time on explaining the function on this challenge. Instead, I spent much more time on explaining some other cool stuffs. The fifth challenge is to calculate the remainder in the integer part when we divide two numbers. I explain the same concept as an example when we cover the theories at the very beginning of this episode. This is the time we implement it using Python. I open the file called 5-full-and-half.py in my VS Code. As usual, here we declare the two variables val1 and val2. I assign them with 5 and 2 respectively. Let's declare one more variable called ini_part and make a function call to calculate the value. In up there, next to the method comment, I define the function for calculating the integer part. So I type def_get integer part. And inside brackets I pass val1 and val2 to the function. In the next line, I return the value of the flow division of val1 and val2. If you noticed it, here I used 2/ sign to conduct the integer division. In down there, I put a comment to before the function call. In that way, we can format the code better. And if you already noticed it, I mistyped the word integer everywhere in the file. So let's correct the mistake. So I select the mistyped word and press Ctrl and D same time to select all the occurrences. Then I correct the mistyped I with A. So, it is one another way that VS Code help us to save the time. So let's print the integer part. Down there, I put a print statement. The next task in this challenge is to calculate the remainder. So I assign the function call to the variable called remainder. And in up there, let's define the function. Inside the function, I return the modulus of val1 and val2. So, as we cover in the theory part, here we use percentage symbol to conduct the modulus operation. As the last line of code in this challenge, let's print the remainder value. So I write the print statement in the bottom of the code. Then it's time to execute the script. So I type Python 3 and the file name in the terminal window and hit enter. We can see that our script accurately calculated the integer part and the remainder for the value 5 and 2. Up to now, I used function more than necessary because I need to explain the concept simpler as possible as I can. But, in some cases there is no point of defining functions for tiny tasks like addition and subtraction. Instead, we can do it in a single go. So, if you check this code, here we have two functions called _get integer part and _get remainder. But both functions are just doing a one simple calculation. Sometimes less number of code lines are much readable than a lot of them. So we can make some changes to this code to reduce unnecessary code lines and complexity. I am going to comment out the two functions I wrote as the first step. So I select them and press Ctrl and / button same time. Then VS Code will comment out those lines for us. In down there, I comment out the function calls as well. Then, in the print statements I directly put the calculations instead of variables. So, I replace the variable int part with the flow division of val1 and val2. In the same time, I put val1 modulus val2 instead of remainder variable. Let's check whether this code is still working as intended. So, let me execute it one more time. Here we can see, we got the same output again. So it is working great. In this challenge, we have to convert a given Celsius temperature into Fahrenheit. The equation for the conversion is as given here. To calculate the Fahrenheit value of given Celsius value, we have to multiply the Celsius value by 9 and divide it by 5. And add 32. As usual, I start coding with the Python file starts with 6. So our first step is to declare a variable called cellval. Let's assign 37 for it. In the next line, I calculate the Fahrenheit value in a single go. That means I don't use function there. Let's keep it simple. So I type faval equals cellval times 9/5 plus 32. If you noticed it, I used brackets to group 9 over 5. In that way, I can ask the Python interpreter to calculate the value of 9 over 5 before anything else. Just keep that topic for the next task since it makes no difference in this line. It only has visual effect is now. In the last line, let's print the calculated value. So that's it. We completed the hard part. Now it's time to execute the script. I type Python 3 and the file name in the terminal and hit enter. We can see that the answer is barely 98. To check our script little bit more, let's change the value of cell val as 100 and execute the script one more time. Here we get 212 as the answer. So, our code is working fine. Here is the last challenge of this episode. In this challenge, we write a Python script to calculate the Celsius value of a given Fahrenheit value. The equation for the conversion is 9 over 5 times F minus 32. I already opened 7-Fahrenheit to Celsius.py file here. Let's start the coding. In the very first line, I declare a variable to hold the given Fahrenheit value. Let's assign 98.6 here. That's the answer from the last challenge. In the next line, we directly calculate the Celsius value and assign to the variable called cellval. So I type cellval equals farval 32 times 5 divides by 9. If you noticed it, I twice used brackets in this line. So, finally it's the time to understand why we put this brackets. If you see it carefully, you can see that we need to calculate the value of farval minus 32 before the multiplication and division. So, I put brackets around farval minus 32. Then Python interpreter knows that it has to give the priority for that operation first. So it will calculate that part first. Then you can see that we have another bracket pair. So in that way we says that we have to prioritize the multiplication over the division. So then Python interpreter will multiply the previous value with 5 as the next operation. And finally, it will divide the final answer with 9. In that way, we can change the priorities of operations. We have to discuss about the priorities in a next day. But I think this is an enough explanation for now. As the final line of code, let's print the answer. And I type Python 3 and file names in the terminal to execute the script. We can see that our script printed the answer as 37.0. Which means our script is accurate. If you noticed it already, in the implementation of equation, one pair of brackets are not doing anything at all. The reason is there is no point of prioritizing the multiplication over the division. So let's remove the unnecessary bracket pair and execute the code one more time. You can see that still we get the same answer as 37.0. So this is the end of the last challenge in this episode. So, it's end of the episode. In this episode, we solved 7 different challenges to polish up our Python skills. All the challenges were about implementing mathematical equations with Python to calculate answers. I personally think that while you polish up your skills, you gained new knowledge as well. I tried to explain each and everything as best as I can. So, if you like our videos and my teaching style, give us a thumbs up. You can share this video to help your friends to learn Python in this cool way. And the same time you do me a favor is helping me to grow this channel. You can subscribe our channel so you will not miss any new tutorials from our channel. See you later.